Hey everyone, welcome to another video by Python Pool. In this video, we're gonna see insertion sort in Python. In the last video, we saw bubble sort. In this video, we'll proceed to insertion sort. First of all, the question arises, what is insertion sort and how it works? Like bubble sort, insertion sort algorithm is straightforward to implement and understand. But as the bubble sort swaps two numbers, that if the preceding number is greater than consecutive number, it swaps them. The insertion sort deals with it in a different way. What it does is it has one number, it will compare that number with the whole list and find its correct position, and then it will place that number there. Like in this list, if I have a number 5, I'll compare 5 with the whole list 7, 8, 2, 4, 5, 6, 3. I'll compare it with whole list, and then what I do, I break the whole list into two parts. One part is sorted array and another part is unsorted array. So in the sorted array, the 5 would be placed at its correct position. In this way, every element in the list is selected, compared with the whole compared with the whole list, and then the list is divided into sorted part and the unsorted part, and the number is placed at the correct position in the sorted list. Okay, so let's run our program and let's see how we implement insertion sort in the Python. Let me code a file. Let me name it as test.py. First of all, we'll be creating a function for the insertion sort. So let me name the function as insertion sort itself. And what it will take a list in the Python. First of all, it will learn first loop, that is getting the number, and it will run in the range of, I'll not start from 0, I'll start from 1. Okay, 1, and up to the length of the list. It would be running this loop. So up to the end of the list, it would be selecting the number. And after selecting the number, I'll create an item variable which would store that number which is selected by the interpreter, which will store the li. Okay, and I'll define my j would be I minus 1, just like our bubble sort. So my j is defined as I minus 1. And what I'll do now, I'll run another loop from the from the last position on the list, and then I'll compare the item with the whole elements in the list, and then I'll divide the list in the sorted and unsorted parts, and I'll place the item at its correct position in the sorted part. So how will we do that? First of all, I'll run a while loop, and while j is greater than equals to 0, while j is a number, while j is not equals to 0, well, j is not less than 0, and one more condition is L of j is greater than item. So first of all, we need to compare the list, and then we need to place the item at the correct position in the sorted list. And how are we placing that? If the Lj is greater than item, then only run this condition, and then the item and the Lj plus 1 would be equals to Lj. So the consecutive point will be replaced by the preceding point. So what we did, first of all, we compared the item with the whole list, and then we we divided the list in the sorted and unsorted parts, and then the sorted part of the list, we placed the item at its correct place. And after placing the item, what I need to do is I need to come out of this loop, and at the Lj plus 1 position, I need to append the item. That is our item's correct place. Okay, and after doing that, what we need to do, we need to return our list. Every element is being compared with the list, and its correct position is being defined, and it is placed at its correct position. Our list is sorted, so we need to return that list. Okay, that's it from this function. Now I'll define one list, and give the fixed contents. You are free to give your own, but I am giving the fixed content because I am going to show you the implementation of the insertion sort algorithm. So I'm giving the fixed content because that content I'll be using in that presentation. So though number mapping would not be happening. Okay, so my content is 8, 2, 6, 4, and 5. That is my list. What I do, I need to call this insertion sort function and I need to pass this L1 list, but it is returning something. So I need to have a variable to store that result. So I name the variable as res, and after this, what I need to do, I need to print the res. And once I save this program, okay, the thing I'm missing is I'm not giving the exit condition for this while loop. So so interpreter doesn't know when to exit this while loop. So I need to give the condition to this while loop. Then hey interpreter, hey Python, when the j becomes less than 0, then you need to exit the loop. But we need to change the value of the j. So we will, after every turn of the loop is being run, then you need to decrement j by 1. So once I save this, once I run this program once again, you could see I got this sorted list. I'll show you this list so you could easily compare the result. And you could see this is an unsorted list and this is list we gained as the sorted list. Now let's see what is the implementation behind this insertion sort. First of all, we gave this list 82645. We gave this list. What happens? It has the number 2 and it compares I have run for loop from the first position. So it would not consider 8, it would consider 2. An item would contain 2. Now 2 would be compared with every element of this list, and then it would be compared and then it would be sorted according to that one. So once the 2 is being compared, in this section, the rest of the remaining of the list is unsorted list and this list is sorted list. So 2 is present at its correct position because 8 is greater than 2. So 8 is moved at the first position and 2 is moved at the 0th position. Now once again item would contain 6. Once again, this time the Python would compare 6 with the rest of unsorted array, not with the sorted array. So 6 would not be compared with the 2. It would compare with 8, 4 and 5. And once it got 8 greater than the 6, it would replace them. Once again, it would consider 4, and now the list is once again here. 6, 8, 4, 5 is the unsorted list and 2 is the sorted list. So in the unsorted list, we need to compare 4. And we found that 6 and 8 both are greater than 4. So fourth correct position of 4 is after 2 but before 6. So in the next step, 4 is placed there. So the white elements after this step, the white boxes represent the sorted array and the colored boxes represent unsorted array. So 2, 4 are now the part of sorted array and the 6, 8, 5 are now the part of unsorted array. Now the 5 is being compared with 6 and 8 and found that 5 has the correct position after 4 but before 6. So the 5 is placed at the middle between 4 and 6. Now once again 6 and 8 are compared and then it found that there is no change. So we got our unsorted array, final unsorted array, that is 2, 4, 5, 6 and 8. This is faster than the bubble sort algorithm and easier to implement too. But since bubble sort algorithm takes two numbers at the same time and swaps them, it takes more time. But in this algorithm, it chooses one number, compare it with whole list, and then places it, and then it divides the list into the two parts, that is sorted part and unsorted part, and place the item number at the correct position in the sorted list. So that's it. I hope you like this video. Have a great day ahead. Thank you.